This problem deals with how gas pressures are measured and expressed in terms of units. We have carbon dioxide gas, which was generated and collected in an evacuated flask. That's shown down here. And that flask, as you could see, is in turn connected to an open-end manometer. An open-end manometer has one end open to the atmosphere and the other end exposed to the gas, and the difference in the height of the mercury is an expression of the difference in the pressure of the gas and the pressure of the atmosphere surrounding it. And as you can see, in this case there is a delta H, as you can notice it right here, and that delta H is the difference between the pressure of the gas and the pressure of the atmosphere. In this case, the pressure of the atmosphere pushes the level of mercury down further on its side than the pressure of the gas does, so the pressure of the atmosphere is larger. So we can say that the pressure of the gas, CO2 in this case, plus delta H is equal to the pressure of the atmosphere. And so if we want to solve for the pressure of the gas, that will be the pressure of the atmosphere minus delta H. And the pressure of the atmosphere is given to us in millimeters of mercury as 753.6 millimeters of mercury, minus the delta H is 174.0 millimeters of mercury. So the pressure of CO2, once you do the calculation, is 579.6 millimeters of mercury. And since 1 millimeter of mercury equals 1 torr, then that will be 579.6 torr. So that's the pressure of the atmosphere, or pressure of the CO2, and you can see it is smaller than the pressure of the atmosphere by the amount delta H. Now we're also asked to, besides calculating P, CO2 in torr, we're asked to calculate it in kilopascals and pounds per square inch. 1 atmosphere is equal to 101.3 kilopascals, and it's also equal to 14.7 pounds per inch squared. So the conversions will need to go from torr to atmosphere, and from atmosphere to first kilopascals, and then secondly to pounds per square inch. So 579.6 torr. Convert to atmospheres first. 1 atmosphere is 760 torr. That's a conversion factor which you should learn. Then from atmosphere to kilopascals, it's 101.3 kilopascals per atmosphere. That conversion factor we will give to you whenever you need it. And once the arithmetic dust has cleared, that will leave us with 77.27 kilopascals as PCO2 in that unit. Similarly, we can convert torr to pounds per square inch. 579.6 torr. Again, we go first through atmospheres. 1 atmosphere, 760 torr. And then the conversion factor from atmospheres to pounds per square inch is 14.7 pounds per square inch for 1 atmosphere, and that leaves us with 11.2 pounds per inch square. So we have 579.6 torr, 77.27 kilopascals, and 11.2 pounds per square inch as three different representations of PCO2. The conversions are all pretty much done in the same way.